Okay. The proceedings have been recorded for your information. This is the business math class, and you can see um, we have 14 weeks of work, and you can look at the syllabus. See the syllabus. You have homework assignments, you have practice quizzes, and in the seventh week, you have a midterm exam. And at the end of the semester, you have a final exam. Before the final and the midterm, you will have, a whole week of practice. During that week of practice, I will make myself available. If you encounter difficulty in solving any math problems, I will help you to solve them. Um, Even today, if there's a topic, there are concepts that you have difficulty solving, or if you have doubts about the solutions to any problems that you did, bring them up. This is the purpose of um, this office hour, to have questions. Um, but I'm considering that as from next week, we'll look at the topic for the week, and I'll do a quick review. Okay, I'll do a quick review. As the topics become more difficult to comprehend, I will do a quick review, solve some examples for you, just in case you have any extra questions, or if you have encountered any problem that you were not able to solve, or you had doubts about how you solved them and whether you got the answer correct or not correct, then I will step in. I'll definitely step in to explain the concept better and maybe solve another example. Having said that, does anybody have any questions that they want to ask?
Not as of yet.
Okay, not as of yet. Were you able to do the quizzes and do the homework assignments? As you can see, there are multiple choice. Were you confident that you were able to grasp the concepts?
So
I'm work you know,
I'm
working
sorry.
through it on my end. No, it's okay, Christine. I'm working through it on my end.
Yeah, same thing. Well, I want to really like understand the mathematics. So I've been reading the PDFs,
Okay.
and right now I'm on the videos and just taking my notes just for recollection. So as I'm doing the multiple choice, that I can actually, follow through with the equations.
Okay. So far, have you encountered any concepts or difficulty with any concepts that you want me to review?
Um, Yeah, I haven't done this since high school.
Mhm.
So, with me was just kind of understanding how to accept what is an independent and like or what is the input and what is the output in certain situations. So I know like one of the examples and when the PDF was just like height is the function of age, and
Mhm.
just understanding like that concept, um, so that, for the future, because I haven't taken a look at any other multiple choice, but I just want to be able to understand like how to manage that part.
Okay. All right. It's very, very, in fact, I'm very glad that you brought this up. Okay. And this is the purpose of this kind of office hour. Many students encounter that problem, and they want to know what is a dependent variable, what is an independent variable. In some cases, in some situations, I would say, in certain aspects of nature, it's easy to say what a dependent variable is and what an independent variable is. But a dependent variable is, a variable is a value that changes from one observation to the other. For example, if you have 10 people, age is a variable, okay? The age is a variable because if you see the first person, their age could be 9.5 years. You can see another person, their age could be 9 years and 6 months. The next person will be 10 years and 4 months. So age is a variable. Okay. So in that case, you ask yourself, what does age dependent? Can age be a dependent variable? Yes. Age is a function of time. Okay. Every day your age changes. So age is a function of time. Okay. Now, look at another situation. Suppose you are driving a car. Suppose you're driving a vehicle. Okay. And ask yourself, you know, if I begin with 40 gallons of gasoline, okay, um, how much gasoline will I have after 60 miles? So the amount of gasoline that you have is a function of the distance that you drive. Okay, so it's easy to know what's the dependent variable because the distance that you drive is independent in the sense that it's already there. Distance is there. From here to Baltimore is 180 miles. From here to Washington, D.C. is 220 miles. And so it's set. There's no changing of it. But and the amount of it that you drive is also set. If you drive from here to there, you have done 1 mile. If you drive from here to there, you have done 50 miles. And so that is set. But then, depending on how much you drive, you can see I use the word depending on how much of the distance that you cover, your gasoline will be so much left in the car, or you have used so much gasoline. So the amount of gas that you use depends on the distance that you drive. The amount of gasoline that is left in your vehicle depends on the distance that you drive. And so this is the way you need to be looking at least from this common sense point of view. This is the way you should be looking at what's a dependent variable and what's not a dependent variable. So the dependent variable is a function. That's what we mean in mathematics. The dependent variable is a function of the independent variable. So do you get that point?
Yeah.
Okay. And so could you maybe remember any of the problems where you needed to think about what is a dependent variable or what's a function of what? Do you remember any of the problems?
Um, well, I mean, what I did, I just listed like the examples since it
Okay.
gave a few examples of I guess of different ways of looking at it.
Mm-hmm.
So it started to make sense to me. Like one of the examples was like the number of officers in a year, determining that, or the months, the days in a month.
Okay.
So once I seen the chart and I kind of understood that, so uh each variable has to have its own function, or let me not say that way. So each input has to have its own output. So if you have something like, if you can't have the same number sending out a different output.
Yes. Okay. So, it's a number of things that I mean, let us think about uh, you know things that really are not random. We're not thinking about randomness yet. Okay.
Right.
Okay. Let's not think about randomness yet. But for example, uh, age. Okay. And height. Okay. Now, age is independent. As time passes, you must age. Everybody must age. Am I
Right.
correct?
Yes.
As time passes, everyone must age. So age in years is an independent variable. There's nothing you can do about it, right? And then, but you have something like weight. So the weight of somebody, or even the height of somebody, depends on their age. Of course, as you can see, some people are not as tall as others for the same age. But one thing that let us look at, say, babies. So let's use babies as an example. The baby is born 7 pounds, okay? By the time the baby is 1 month, the weight of that baby is going to change. The fact that 1 month, the number of months that the babies will pass through the 1 month, the 2 months, the 3 months, the 4 months, 5 months, 6 months, 7 months. There's nothing you can do about that. The 1 month will come, 7 months will come, 8 months will come, 9 months will come, 10 months will come. You cannot change that. All right. But what will be changing is their weight. So weight is a function of month or age. You get the idea?
Right. Yeah.
Yes.
Now, sometimes, well, as we go along in this class, you will find out that the functional relationship between a dependent and an independent variable is not always a straight line. Okay, so we're going to learn about those as we go. Okay, the sense that some things change at different rates, and even the rate of change could be a very complex process. So, but for now, at least I believe and I hope that concept of functions is clearer to you.
Yeah, it absolutely makes sense. That's why I was saying that as I was going through the examples and really understanding it, the more examples I was reading, the more I understood. But
Okay.
definitely when I started to read about the age, it kind of like threw me off a little bit of understanding what was the input and what was the output. But when you say it that way, like something that um
A value that depends on another one.
exactly.
Okay, so the value that depends on another one is the output.
Can you
And
repeat that for me one more time?
A value that depends on another one is the output.
Okay,
The
thank you.
input is that value that you cannot do anything about, like age of a baby in months. 1 month, 2 months, 3 months, 4 months, 5 months, 6 months, 7 months, 8 months. You cannot do anything about that. Time will pass,
Mhm.
whether or not you like it. But the weight of the baby will depend on how many months the baby is. You get the idea? So the output is weight. Now, if you are traveling, if you're driving your vehicle, how much gasoline that you're going to use is the output, because the distance that you're going to travel in, if you go from point A to point B and from point B to point C, there's nothing you can do about how much distance that is. You cannot do
Okay, and
anything
that's the
about it.
output. Okay.
Okay, so that is the input, the amount of distance that you have covered. Now, how much gasoline that you use will not depend on the distance. So the amount of gasoline that you use becomes your output.
Okay.
You get the idea?
Yes.
Okay. All right. Does anybody have any other questions?
Can you explain example number 6? It said which of these tables define a function, if any?
Okay. What is it? Is it in chapter 1 or in chapter 3?
Chapter 1,
Chapter 1, 3. Is it
example
chapter
6.
1.3 or chapter 1.1?
It's on the chapter 1 underscore 1
Okay.
PDF.
Okay. I'm going to get into it right now. 1.1. Okay, and it says example number what, 6?
Correct.
All right. Okay. Which of these tables define a function, if any? Right? Input, output. The first and second tables define functions. Okay. In both, each input corresponds to exactly one output. All right. So input 1, output, input 2 units of input define only one output, right? 1. So when you have an input of 5, an input of 2, you get an output of 1. If you get an input of 5, you get an output of 3. You get an input of 8, you get an output of 6. Okay? So what you're seeing is that the larger the input, the larger the output. Okay. Number 2, the second table. Okay? If you have an input of -3, you get an output of 5. When the input increases from -3 to 0, the output decreases, right? Okay? I mean, the output decreases. And here, if you get an input of 4, the output goes back to 5. That simply means that the relationship between output and input is not exactly linear. It goes up to a maximum and then it begins to change again. But here
Okay.
you see an input of 1, the output is 0. You have an input of 5 and the output is 2. But again, you have another input of 5 and the output is 4. So you don't have a unique output for the particular size of input. Therefore, the third table is not a function. You get the point?
Is it because it went down? You mentioned that is because it's not a straight line. Am I getting that correctly?
No, no. No, that's not what we mean. Because a function does not have to have a straight line relationship. Okay? And we're going to talk about that in the future. But for a set of values to represent a function, every input value gives rise to a unique. Do you mark the word unique? Every input value will give rise to a unique output. So you can see here that input value 5 occurs 2 times, but the output is not unique. First, you have an output of 2 for the input of 5, then you have an input of 5 that also gives you the output of 4. So that's the input-output relationship is not unique.
Okay.
You know what unique means?
I'm sorry, I didn't hear the question. I didn't hear that last question.
Okay, I said every every value of input gives rise to a unique output. Unique. You know what unique?
Yes, different.
You cannot have a particular value of input that gives you 2 different kinds of output.
Okay.
In table 3, you can see an input of 5. What is the output?
Yes, 2 and then 4.
You see another input of 5 and gives you what output?
4.
4. So the output-input relationship is not unique.
Okay.
Okay? All right. Any other questions? Feel free, feel free. Okay? So I take it that you don't have other questions. You don't have problems that we have difficulty solving, not yet. So by next week, I'm going to take a different approach. I'm going to begin a different approach, and just use this week to introduce us. We know how the class is going to be conducted. Before our midterm exam and our final exam, there's going to be a whole week for review. And during that, the office hour for that week, I'm going to take it upon myself to review questions. I will welcome that you may even have your own questions to bring up for me to review before I get into my own review that I will put together.
So Professor, because this particular assignment is due, if I'm not mistaken, on the second or the third, right? Which is
On the second,
on the
according to the
second.
syllabus.
That's this Sunday. So next Thursday when we meet again, would you, if we have any questions on this week's assignment, would we be reviewing that as well, or?
Bring it up, because I'll rather be reviewing the second week's
Right.
topic.
Okay.
But if you still have issues with the first week's topic, please feel free to bring it up.
Okay. Thank you.
Okay. All right. Nice having everybody here.
Yes.
And I'll
Okay.
see you guys next week.
All right,
Yes.
thank you. Have a
Thank
good night,
you.
guys.
You too. Thank you.
All right.